The question says two salts A2X and MX have the same value of solubility product of 4 into 10 raised to minus 12. The ratio of the molar solubilities, that is molar solubility of A2X upon molar solubility of MX, will be equal to. So let's find the solubility for this A2X. Now the KSP value is given to us as 4 into 10 raised to minus 12, which will be equal to, when we write the dissipation of A2X, we get 2A positive plus 2X2 negative. Therefore, we have solubility product to be equal to A positive whole square into X negative. So therefore 4 into 10 raised to minus 12 will be equal to 2x whole square into x, that is equal to 4x cube. Therefore we have x value to be equal to 10 raised to minus 4. This is the solubility of A2x. Now let's see for the salt MX. When salt MX dissociates, it dissociates as M positive plus X negative. Now let's assume that there are Y moles of MX in the beginning. After dissipation, we get Y moles of M positive and Y moles of X negative. So therefore solubility product KSP will be equal to 4 into 10 raised to minus 12, which is equal to number of moles of M positive into number of moles of X negative, which is equal to Y square. So therefore we get the value of Y as 2 into 10 raised to minus 6. Now on taking both the ratios of these solubilities, we get 10 raised to minus 4 upon 2 into 10 raised to minus 6, which is equal to 50.